Module 3, Lesson 2 problem set, we're going to jump into using kind of our area diagram, our area model as a reference point for our multiplication skills. So for question number 1, it says a rectangular porch is 4 feet wide. It is 3 times as long as it is wide. So I know it is 4 foot, 4 foot, and 4 foot. Which means that the total length, when it's 3 times larger, would be 12 feet by 4 feet. So label the diagram with the dimensions of the porch. It would be a 12 foot by 4 foot porch. Then we need to find the perimeter of the porch. Since it's 12 by 4 foot, we know it would be 12 plus 12 plus 4 plus 4. This would be 24. This would be 24 plus 8 would equal 32 feet for the perimeter. Okay? For here, a narrow rectangle banner is 5 inches wide. And it is 6 times as long as it is wide. So it's going to go on quite a bit. And it doesn't need to be perfect. We have 1, 2, 3, 4, 5, and 6. So it would be 5 inches, 5 inches, 5 inches, 5 inches, 5 inches, and 5 inches. When I add them all together, or do I do 5 times 6, we get 30 total inches. So let's draw a diagram of the banner and label its dimensions. It would be 30 inches by 5 inches. Okay? In part B, it says find the perimeter and the area. Perimeter equals, could be length plus width plus length plus width, or length plus length plus width plus width. It doesn't matter as long as all 4 sides are accounted for. So if I do 30 plus 5 plus 30 plus 5, that's going to equal 60 there, plus 10 equals 70 inches. For area, it is going to be 30 times 5. And what's interesting is I can actually hide the 0 and do 3 times 5 is 15 and then add the 0. But interesting enough, it would be inches squared or square inches. They mean the same thing. 150 inches squared for the area and 70 inches for the perimeter. So over here, they will give you the area and the length, and you're going to need to figure out the width of the rectangle. Okay. If you want to draw a second rectangle, the same length but 3 times as wide, draw and label this second rectangle. So you're going to take this rectangle and make one 3 times wider, identifying the perimeter. Over here, let's look at this one. The area of Betsy's rectangle sandbox is 20 square feet. The longer side measures 5 feet. The sandbox of the park is twice as long and twice as wide as Betsy's. So I have Betsy's sandbox, and this is a big picture for it, but it is 20 square feet with a length of 5 feet. Okay? In order to figure this out, I know what times 5 equals 20, and that would be 4 feet. Okay? So I know I have my drawing and labeling, and the perimeter would equal 5 plus 5 plus 4 plus 4, equaling 18 feet. So we have 4 foot width, 5 foot length, 20 square feet for the area, and a perimeter of 18. Our sandbox at the park is twice as long and twice as wide. So if it's twice as long and twice as wide, it's quite a bit bigger. We know 5 feet, and it would have to be another 5 feet. In this case, it would be 4 feet, and this would have to be 4 feet. Okay? So this would be 20 square feet, 20 square feet, 20 square feet, and 20 square feet. And what's interesting is, from here, we would know that the area would be 80 square feet, whereas the perimeter 10 plus 10 is 20, plus 8 is 28, plus 8 is 36. So area is 80, perimeter is 36. What's interesting is for C, what's the relationship between the two perimeters, between 36 and 18? How are they related? What would the area, and we kind of found that already for D. E asks us, how is the area of the sandbox of the park related to Betsy's, and how did the perimeter and area change between those two? Once we recognize the area and perimeter of each of the sandboxes, we can see how they are related and fill out the rest of those questions.